This is a DC-DC boost converter. The model name is MT3608 that can allegedly output 2 amps of power. We're gonna test that, and we're gonna test 2 components on the thermal camera, the diode and the regulator itself. I performed 15 different tests with thermal camera and voltage drops and everything, so let's get into it. Hello world and welcome. First, let's talk about the environment and how I am testing all of this. So first, the temperature is around 24 degrees Celsius, the humidity is 25 around. All the test times are at 30 minutes, 15 different tests. All of the tests are in open air, so no cases, no anything, without any heat sinks or additional airflow. I'm going to measure component temperatures, the stability, the voltage differences, the amp rating, and the efficiency. About the voltages, is going to be from 3.3 to 5, 12 and 24 volt output, from 5 to 12 and 24, and 12 to 24. We're going to start slow and ramp up the amperage. Now let's talk about the results. First batch is for 1/4 of the amp. So from 3.3 volt to 5 volts, everything looked good. The efficiency was great, the temperature is perfect, and the voltage difference is 0. So I set it to 5 and it was 5. For 3.3 and 12 volts, there's a little bit of the voltage sag, and the temperature's still good. I liked it pretty much. From 3.3 to 24 volts, well, not gonna happen. We lost more than 7 volts on the output, and the regulator went to 123 degrees temperature, so this is a no-go, so we lost this one. From 5 to 12, little bit of a voltage sag, but efficiency is good and the temperatures, yeah, like great. From 5 to 24 volt, well, we didn't get the full 24 volt, we lost half a volt. The efficiency is at 81, and the temperatures, yeah, they heated up, like even at this small amperage. For the 12 volt to 24 volt, well, it was a little bit of a voltage drop and the temperatures were great. The efficiency is around 90%. For a half amp test, from 3.3 to 5 volt, it's barely noticeable, so on voltage side it's perfect. The efficiency is around 85, and the temperatures, yeah, like really solid. You can even put this in some PLA casing, it would be fine. For 3.3 to 12 volts, yeah, we lost it. It's more than 2 volt drop, so not gonna happen. The temperatures, yeah, rose, so this is a no-go. For 5 volt to 12 volts, the voltage drops minimum. You can see it here. The efficiency is pretty much good. The temperature is good. So yeah, this is a good result. For from 5 volt to 12 volt, well, the test was only for 1 minute, and then it just shut down. The voltage drop was enormous, so almost 7 volts, so yeah, it didn't happen, and the temperature, yeah, rose, but who cares, because like, yeah, it can't sustain it. From 12 volt to 24 volt, the output voltage is great. The efficiency is around 91-92%. And the temperatures, yeah, pretty solid. Yeah, not don't use a PLA, or I would say even PETG casings, but ABS, ASA would be fine on this one. On 1 amp test, yeah, we lost a lot of. From 3.3 to 5 volt, the voltage drop was more than 2%. So check if your device can handle it. The temperatures were around 85 degrees, so more or less fine, but think of the casing and the ventilation. From 5 volt to 12 volt, well, not gonna happen. We lost almost 3 volts, and the temperatures, yeah, they were not great at all. So we lost this one. From 12 volt to 24 volt, again, didn't happen. Almost 4 volt drop, and the temperatures, yeah, rose a lot. So yeah, this is a no-go. So 1.5 amp test from 3.3 volts to 5 volt. Well, not gonna happen. More than 1 volt drop, and the temperatures, yeah, weren't great. But yeah, it's not gonna happen. So in the end, yeah, it can't output 2 amps. Maybe some heat sink or something maybe could give us some boost. But remember, the package is very small. So it's almost 37.5 millimeters to almost 18 millimeters, and the height is almost 7 millimeters. So the package is very small. There's no room to dissipate the heat. So yeah, for like small projects, fans or something, yeah, it's good enough. If you like the tests and the time that I spent on these, give it a like, subscribe, and share it with others. So yeah, thanks. Bye.